Okay, so we'll take a look at question 1 first. First section is asking us to draw the structure of the 3 branched chain alkenes. So this is the first point to note. We can't have the straight chain isomers, so nothing based around pentene, so pent-1ene, pent-2ene, for example. They've got to be branched chains. So when we've only got 5 carbons, there's only really 3 ways to really do that so that you can have an alkene. So we can have a skeletal structure or a carbon backbone structure which has to be based around 3 versions of this type of molecule. We can't have the 2,2-dimethyl propane version because we wouldn't be able to put a double bond into that structure, so we know that one's not viable. And so what would happen is we'd have a double bond in that position. There's no need to have a double bond in the other position here because that would be the same position rotated round. We also have a double bond possible on this one, and then we have a double bond in the but-1ene position. So that gets us the first aspect of the question. The second part of the question is then asking us to form the dibromo compound when these alkenes have reacted with bromine. So what we're going to have to do is electrophilic addition to the double bond. So we're going to ultimately get rid of the double bond in each of these 3 examples and then place bromines across that double bond so that we get the dibromo species on each of these. And so that's relatively straightforward once we get the relevant bromines added onto the molecule. And then the final part of the question, which is the more difficult part, is then asking us to identify the NMR, which has got 3 peaks within its spectrum. So what we can do is we know that we are going to have 3 protons around this carbon here. We're going to have 2 hydrogens around this carbon here. There's going to be no hydrogens around the central carbon. There'll be a couple of hydrogens on here, and there'll be 3 hydrogens on here. And that's going to give us 4 environments, so it's not that one. The one down here is going to have 2 hydrogens on there. Remember, you're saturating up to get 4 bonds around each carbon. There'll be 1 hydrogen on here, 1 hydrogen on here, and then a series of protons on there, 3 protons on there, which are equivalent to those protons as well. So both the similar identical chemical and magnetic environments. So those groups will be identical or equivalent. So again, 4 regions on there. Now the one which is obviously now presumably the answer is we would have 3 protons on here, 1 proton on here, and then again 2 equivalent methyl groups there. So this is the one which is going to give us 3 chemical environments. So this is the correct answer to this one. But what we have to do is just quickly have a look at the splitting patterns for those 3 peaks. So remember, this is where we have the protons in an adjacent carbon giving rise to splitting. So this one here, or the peak due to these methyl groups here, will have an integration of 6 protons. However, there's no hydrogen on the adjacent carbon, so that will be a singlet peak. Okay. This end carbon will have an integration ratio of 3 hydrogens and is next door to a carbon which would have a single hydrogen on it. So this will be split into a doublet. This one will be 1 hydrogen integration, so the smallest peak on the spectrum. That will be next to these 3 protons, so that will be split into a quartet. Remember, n plus 1.